I'm sharing my screen. Can you see my screen?
Yeah, I can see your screen now.
Great. Okay. Yeah. First of all, I want to thank you for attending this meeting. I'm really happy, to introduce you our Alphamos product, especially Alphamos Enos. Okay. According to my communication with Mr. Sapri, today, so we will, walk you through Alphamos Enos very quickly, and then we can focus on applications like how Alphamos Enos is applied in quality control and research and development in different industries. Yeah. Please feel free to stop me if you have any questions during the presentation. So for this presentation, the agenda is the first part, introduction, then product portfolio, then a few simple case studies, and then wrap up and Q&A session. Yeah, our core business, Alphamos, in our core business is empowering sensory testing for industrial markets. So we develop and sell leading edge sensory analysis solutions for smell and aroma. We have Practice Enos. For taste analysis, we have this S3 E-Tom. For visual aspect analysis, we have Iris EI. The facts and figures. Actually, Alphamos is the first company to introduce Enos on the market. So we are the global leader in Enos, E-Tom, and EI. So Alphamos was created back in 1992. So it's more than 30 years history. We are a listed company, traded on Paris Stock Exchange. We have 6 offices in different countries. If we look at the one in the middle, Alphamos France is based in Toulouse city, and which is our headquarter office. We also have office in US and in Japan and also in China. So our China office is located in Shanghai, and we are taking care of Southeast Asia market and also Chinese market. And Alphamos is the leading provider of sensory analysis systems. There is a very unique feature of Alphamos Enos. We are able to identify close 142,000 VOC compounds and more than 3,790 sensory attributes in our Practice Enos database. Yeah. So it's very unique, and it's very powerful for odor and smell analysis. Alphamos sectors and markets. So from this slide, we can find our focus. Alphamos provides a full sensory instrumentation line for product authentication, certification, quality control, and product development for like food and beverage. Food and beverage industry is our main focus. For beverage like tea, coffee, dairy, juice, drinking water, etc. And also packaging, body care, pharmaceuticals, tobacco, flavor and aroma, and of course, academies, institutes, and universities. So no matter from raw material through processing steps until finished products, in all different stages, our products can be applied for. Speaking of application expertise, so there are mainly 2 buckets, as we know. One is R&D, the other one is QC or QA. So in terms of a product design and development, here we list down some typical applications such as contamination identification, packaging selections, and packaging interactions. As we know, especially those dairy and beverage products, when we use this PET bottle or other, like paper, box, etc., there will be some interactions between the product and the packaging materials. So by using ENOS, we can also investigate these interactions. And also for off-blending or spoilage, aging, storage effects, stability, shelf life, ingredients substitutions, new formulation development, competitors benchmarking, adulteration, flavor scalping, etc. And speaking of QC and QE side, no matter for raw materials and finished products, we can see products like water, soft and alcoholic drinks, edible oils, cereals, aroma, seasonings, soups, meat, frozen food, dairy products, coffee, tea, chocolate, even packaging, plastic, paper, and petrochemicals or solvents. There is a myth about smell and taste. So according to science, around 80 to 95% of what we think of as taste is actually smell. What we perceive with the taste is the flavor. It's a combination of savor, what we do taste by our tongue, like the common 5 basic tastes, salty, sour, bitter, sweet, and umami. Yeah. And second part is retro olfaction. That is what we smell with the back of our nose, which actually it's a majority. Most of them are caused by the VOCs, volatile organic compounds. So it's a response of a complex mixture of compounds and signals. So we may have this, experience when we catch a flu. If we have some food or have some drinks, they don't taste like before. The flavor is much less. The reason is because we have our nose is kind of stopped, so we cannot feel the VOCs. We cannot feel the flavor. So that's why the food tastes differently with common days. Yeah. So smell and taste are not identification and quantification of each compound of a mixture. It's a systemic response to a set of signals of pattern recognition. Human sensory challenges. Yeah, our human sensory panel are highly represented in food and beverage industry and are facing several challenges. Yeah, such as individual subjectivity. We all have our own, preferences, different thresholds for sweetness and bitterness. For example, some person they prefer, food more, like sweeter, and they like the sour, etc. So we all have our own subjectivity and our own, threshold. So limited sampling capabilities. Yeah, according to our experience, especially in the big companies like Coca-Cola, they do have strict limitation about the sampling amount for every panelist, such as they can, one panelist maximum can take 7 rounds of this sensory testing. Otherwise, there will be sensory fatigue. So their nose and tongue will not be sensitive anymore after taking 7 rounds of tests. Yeah. Humans are prone to sickness, challenges of motivation. I think, especially in Asia, most of human sensory panelists, they are not, sensory testing is not their only work. They need to do something else, like in the lab. So sometimes, day after day, there could be a lack of motivation to do such tests. Continuous calibration needed of sensory panelists, overload with multiple samplings, and disruption of workflow and high costs. So Alphamose provides solutions. By using Alphamose ENOS EI, there are some advantages. So, first of all, it's fast. For example, 6 minutes per sample for enos, and multiple sampling with various flavors. Yeah, and ability to test challenging products, such as some pharmaceutical products. We all know sometimes they're quite bitter, and also some harmful products or harmful smells, etc. And also like pet food or animal feeds, etc. So machines don't have such issue as us, human beings. Yeah. So Enos Eton AI can test that kind of products with no issue. Reliable and easy to use, ease of training, calibration is easy and no sensory preparation, and immediate product testing ability. So in general, most solutions can provide an efficient way to supplement or enhance human sensory panels. And this is a summary of the advantages and benefits. Improve the reliability of sensory assessment, get easy to understand the results, optimize the sensory features of your product, gain competitive advantage, and also take faster decisions at the point of production, especially in QC application. And then we go to the product portfolio. This one is a comparison between human perception and instrumental process. So basically, most products are mimicking human sensory perception. So we all know we use our nose, tongues, and eyes to acquire the odor, taste, and the visual information. And then we do the training and analysis by our brain. So in the end, we can have this perception like, oh, it's a good one, or it's a bad one, or it's a banana, or it's ice cream. Yeah. So most Enos Eton AI, we're using flash GC sensors and a camera to acquire this odor, taste, and visual information. And then we can do the training and analysis by our software and database. So in the end, we can have similar results with human, like it's a good one or it's a bad one. Yeah, or we can recognize it's an apple or it's a banana. And then we go to the product. Yeah. So since you are mainly focused on Enos, so I will go very quick for Eton AI. So S3 Eton is good for overall taste profile analysis. If we look at the picture on the left, you can see a computer with software inside, trackless electronic unit in the middle, and auto sampler with sensor array, on the right. So you can see there is a green cover. So under the cover, we can see there are 7 yellow stamps. So those yellow stamps are actually the S3 sensors, plus 1 reference electrode and agitator. They form this sensor array for testing samples. For acquire the substances dissolved in the water or water ethanol solution. Actually, it's similar with our human tongue, because when we taste some like soup, we can feel it's salty or it's umami. The reason is because the ions and molecules, they have this reaction with the receptors on our tongue, and then the signal go to our brain, then we can feel it's salty or it's umami. Yeah. And the S3 Eton can do taste ranking based on taste attributes intensity, such as the example on the right. You can see this one is a sourness intensity scale. So you can see the sourness of these 4 samples can be ranked, on a scale from 0 to 12. Yeah. It's a relative intensity for sourness. Yeah, we can also provide the saltiness ranking, saltiness scale, umami scale, sweetness, bitterness, spiciness, even like metallic, etc. So analysis in liquids. And you may wonder, how about if our products are solid or like half solid, half liquid, like sauce? Yeah, we have standard operation procedure for those kinds of samples preparation. So no matter it's like it's a bread or it's like liver sauce or other things, we can test those samples reactory time, using after sample preparation. This one is EI. The name is Iris. So if we look at the picture on the top left, we can see the computer with software, a big lightning cabinet. So inside this cabinet, there are cameras and also different lenses and two FID source, one on the top, one on the bottom. So basically, it can provide sustainable and consistent lighting conditions for sample testing. Yeah, and also we can use software to acquire like color compositions, like this column chart, the color composition of this cheese cheddar. And also from the visual map, based on PC map, we can have this, we can observe the overall, color or shape similarity between different samples. So Iris EI is good for colors and shapes analysis. Yeah, we have different color systems, like common ones like RGB color system or LEB color system. And also for shapes, we can have this circularity measurement, and and also the sample size, etc. So no matter for whole surface or selected portions, Iris EI we can select. To take, for example, these 4 pieces of cheese, we can treat them as one sample. We can also select, each of them as an individual sample. Yeah. Then we go to Avamos Enos, which is our most popular product. So Avamos Enos is a combination of hardware, software, and database. So our software name is AlphaSoft. Database is called Alchem-based database. So this slide shows the main feature of Hercules Enos. If we look at the picture, we can see on the table we can see the computer with software and database inside. And also we can see the auto sampler in the middle. So it's a PALSI auto sampler, for automatic sampling. And the box on the right, we can see it's a Hercules new analyzer. So it's like many components inside Hercules new analyzer, including the injector, 6-way valve, pre-concentration trap, and 2 different columns, and 2 FID detectors, and all EPC modules for gas pressure and flow control, etc. So it's a very concentrated like instrument. Yeah. And under the table we can find the gas generators. So on the right we can see the hydrogen generator for producing hydrogen, and on the left we can see 2 units. So the lower one is air compressor, and the one on the top is zero air generator. So these 2 units is for supplying high purity compressed air. Yeah. So in Hercules system, totally there are 2 gases are needed. One is hydrogen, the other one is zero air. So hydrogen will be used for 2 main purposes. One is we're using FID detector. So which means we need hydrogen to burn with oxygen. And secondly, we use hydrogen as carrier gas. Yeah, so in normal GC and GCMS, helium and nitrogen are being used as carrier gas. So speaking of the performance, helium is better, a little better than hydrogen, much better than the nitrogen. But we know that helium is very expensive, so that's why by using hydrogen generator, it's much safer, and hydrogen performance is also quite good comparing to nitrogen and helium. So that's for hydrogen. And for zero air, since inside the FID detector, you will need oxygen, to burn with this hydrogen. And secondly, the zero air will be used for flushing the syringe to clean the system. Yeah. So basically, Hercules flash GC nodes is good for overall odor profile. It's like for like fingerprint analysis or benchmarking, etc. And also it's good for chemical composition analysis. Yeah, we can possibly identify the compounds evaporate from our products, because most of our customers, they will select headspace injection, headspace analysis, which is, for example, we put 1 gram or 2 grams of our products into this 20 ml headspace vial, and we crimped the vial's cap, and then the autosampler needle will extract the gas components from the vial and inject into Hercules neo analyzer. So this is called headspace analysis. And Hercules analysis is very fast. As mentioned earlier, average it can reach like 6 minutes per sample, and with very high throughput. So by default, in Neo 300G, we can run 90 samples in one sequence. And there is an embedded pre-concentration trap inside to increase the sensitivity. Yeah, so by using this one, we can increase the sensitivity for most compounds, molecules, we can reach like ppb levels for most VOC compounds. And there are 2 different columns and 2 detectors inside Hercules Neo Analyzer. So 1 injection, 2 chromatograms. So by using these, first of all, we can obtain more information about our products. And secondly, we can use Covas retention index to identify the compounds in our products. Yeah. And liquid injection and headspace injection both are available, but for liquid analysis right now it's only available in Neo 300, the highest configuration. And we have 7 different configurations to match your needs. If we look at the table, we can see from Neo 50, the basic one, no autosampler will be no autosampler in this. We need to do manual injection, and the lowest, the basic model, until Neo 300G and Neo 300, the highest model, the best configuration. And speaking of the hardware and software, we can see the dot means included, option means can be added on. And we can see the injection mode, sample capacity, Neo 100, Neo 150, 45 position, meaning we can run 45 samples in one sequence. Neo 200 to Neo 300G, 90 samples in one sequence. Neo 300, 40 for headspace, and 3 multiplied by 54, for liquid injection. FID station meaning gas generators corresponding to these 3 units: hydrogen generator, a compressor, and zero air generator. For software, there are also some different combinations, but don't worry, we will recommend suitable software configurations to our customers, and then all these can be added on even on like a Neo 100. Even in Neo 100, you can also have all these software options. If you look at the picture, we can see new 50, this Hercules unit, computer and software, and of course, startup kit like syringes, like tubing kit, etc. will be provided. New 100 and new 150, a smaller, a compact auto sampler will be provided, corresponding to a relative lower sample capacity. But from new 200 to new 300G, new 300, this a larger auto sampler will be provided, corresponding to a higher sample throughput. And then we can go to the software. So this one shows the raw data format for Enos, ETON, and EI. Since we are using dual flash GC technology, so the raw data will be gas chromatography peaks. There will be two chromatograms in one raw data. And in ETON, the raw data is sensor signals, and in EI, it's the color and shapes information of our sample. There are many different qualitative and quantitative models in our software. Yeah, for example, sensory ID, sensory identification. It's only for Hercules Neo. It's mainly used for quality control, but it also can be used for R&D, for quickly screen out, the off orders or the most different compounds between different combinations, etc. So yeah, the picture on the first picture, we can see this one is example of sensory ID model. So the principle of sensory ID is we can build the model with good products. A good product means with good sensory, good odor quality coming from different batches, and then we can build this model. So the formulation or the algorithm of this model, yeah, it can adjust and learn and calculate and form this acceptable area. Yeah. And then we can select several good or bad or marginally or acceptable good or slightly bad samples to validate the performance of the sensory ID model. And then this model can be used for daily quality control. Yeah, we have many customers that are using this sensory ID model for quality control, like Coca-Cola and Mengniu Dairy in China, and even like Vita Coco in Singapore, etc. Yeah, many customers are using this one. Principal component analysis, PCA. Yeah, if you are familiar with sensory analysis, I think it's not strange to you. Yeah, it's the principle is using dimensionality reduction theory to project the overall odor, taste, or visual information on a 2D map. So by looking at this PCA map, the closer the two samples are, meaning they have similar overall odor or taste. Statistical quality control is another quality control model, this one. So the algorithm is different with sensory ID. We have some customers like Henkel, they're using this model for quality control. Discrimination factorial analysis, it's a group recognition model, such as we want to use Enos to identify the origin of these coffee beans. Yeah, we can do we can run the coffee beans, for example, coming from 3 different origins, and then after building the model, we can project unknown samples or new batches into this model, so we can know this new batch is coming from Africa or coming from Asia, etc. Shelf life model. Yeah, we can use this model to optimize the shelf life of our products, and also we can compare the stability of our product, under different storage conditions, such as different temperatures, different humidity, or even we can compare the product's freshness, with different packaging materials using this shelf life model. And partial least square PLS model, it's a quantitative model. It's mostly used for correlating with human sensory panels scores. For example, the older grading, especially in some, in automobile industry, for example, they have this strict requirement regarding this older grade. They have this score system. For example, higher than 3.5, it's unacceptable, it's bad smell. Lower than 3.5, it's acceptable, etc. We can use this model, to combine the human sensory evaluation results with INOS data. So this model can combine these two into this PLS model. And after that, we can use the PLS model to calculate the sensory scores, for new batches or for blind samples, etc., without human testing. Yeah, it's like we do a training to INOS, and then the INOS can work as human to provide sensory evaluation results. The following two slides are some detailed explanations. I will not go to all these details. And then outcome base. Outcome base is only available in INOS because this one is a chemical and sensory database. So as mentioned earlier, there are more than 142,000 compounds information inside, around 4,000 compounds with sensory attributes, and around more than 2,000 compounds with human smell detection thresholds. And it's very easy to use, directly integrated in AlphaSoft. Yeah, this one is an interface, an example of AlphaMOS outcome base. If we look at this compound, limonene, so we can find the information such as formula, Cas number, molar mass, retention index on different column, DB5, 1701, DB1, DBX, etc. And beyond that, we can also find sensory descriptors in here. So limonene smells like citrus, like orange, etc. And also all the thresholds in here. So you can see the recognition value of limonene is 2.25 milligram per cubic meter in the air. So which means the mass of this compound, the mass of limonene, if the mass reaches 2.25 milligram in 1 cubic meter space, then with human nose we can recognize it. And also we can use this database to identify the peaks in our raw data by using collapse retention indexes. And then we will go to the application. Can I know, do you have questions, until now, before we go into the applications? Or it's quiet. Then I assume there is no questions so far. Okay. Yeah, I will continue to introduce you some applications of AlphaMOS product. So AlphaMOS solutions cover a wide range of applications. There are tremendous examples and know-how. Here we provide a few examples. So for new product development, shelf life, competitors benchmarking, taste masking, and for quality control examples are like batch consistency and cleaning place. So the first example is an aging study of edible oils. So there are three different edible oils: palm oil, soybean oil, and colza oil. So we run those different oil samples at different time. For example, on different months, we can find the P0, S0, and C0 fresh sample, and after like 5 months or 5 weeks, and then 10 and 15. So we can find, along with the aging time, the rancidity level is increasing. But among these three products, we can find the colza oil rancidity is increasing rapidly and dramatically. But the palm oil and the soybean oil, they are relatively stable. Yeah, so this study, this example can tell us the colza oil is the least stable among these three products. So you may wonder, how do you know the y-axis is rancidity? The reason is because we have a lot of experience in this rancidity analysis and oxidization analysis, etc. So we can track down the compounds related to rancidity, such as the common aldehydes and some acid and other types of compounds. So we can monitor the rancidity level by tracking those molecules' content along with time. And so we can find the rancidity level of different products along with time. So it's an example of aging study. And this one is a benchmarking example for beverage. For example, right now, we want to develop a new product which is similar to our target product. This target product, for example, it could be the most popular product on the market. So we want to design a similar one, maybe have similar odor or taste with this target. So we design different formulations, and then we can run the formulations and target product with enos, and then we can have this, we can have this overall odor similarity evaluation result from the PCA map. So from the principal component analysis result, we can find that formulation 2 is the closest to this benchmark, which means it's the best match to our target product. So yeah, and in addition, we can also compare the samples. We can find the most different molecules between each formulation and the target product. Yeah, so that it will be helpful for us to optimize our formulation or to adjust the direction of our formulation design. So this one is a benchmarking application. And this one is taste masking. It's an ETON application. It's called taste masking efficiency in oral medicines. So the product is like children's syrups. So we know the most medicine taste bitter, so we need to use placebo for masking the bitterness taste. So by running the samples with S3 ETON, we can compare the distance between formulation, the active formulation, including API, placebo, etc., with the placebo. So the smallest distance between placebo and formulation means it has the best masking efficiency. And then QC example, batch consistency. Yes, this one is sensor ID model. It's like I mentioned, sensor ID is a patented model in Alphamos for fast comparison of entire chromatograms without integration needed. Yeah. After we build the model, the samples result, pass or fail, can be displayed in the software. Yeah, just simultaneously after each sample's acquisition. Yeah, for example, we have run the first sample, and then good or bad result can be displayed in here. And then the second sample, third sample, fourth sample, fifth sample, etc. And beyond that, in this sensor ID model, we can quickly find out why the sample is judged as failed. For example, we can find why this sample is judged as failed. The reason is because there is a new peak. There is a new compound, presented in this batch, while this compound doesn't exist in the reference groups, reference samples. And secondly, we can see the green one. In the reference samples, this compound content is very low, but in the new batch, we can see the compound concentration is much higher than the reference samples. So that's why this batch is judged as out. And by using outcome-based database, we can identify this new peak, this new compound presented in the new batch. So we can find out what compound it is, and we can find the sensory descriptor of this compound. So it's not only for quality, for odor quality identification. Yeah, it can also provide us the possible reasons why this batch is judged as out, and we can track down, we can investigate the off odor compounds. And this one is milk quality control using SQC model. The algorithm is a little different with sensor ID. But using SQC model, we can select even one or several compounds to monitor. For example, we only select 5 or 6 typical milk flavor in our product, or we can select like several the most commonly off notes in milk product to monitor their concentration. So it's flexible. CIP cleaning in place, especially in the beverage and milk and dairy industry. They're gonna use this production line to produce different products, such as energy drink, and maybe juice, and drinking water product, etc. So every time if they want to switch the production line, for example, from energy drink to juice product, you need to clean the pipes, the tanks, etc., using different solutions, such as diluted acid solution or diluted alkali solution or hot water, etc., to make sure there is no flavor residue inside the pipes, inside the tanks, etc. Otherwise, the juice product will smell or taste like energy drink. So it will be a bad thing. So that's why we can use Enos. We can use Enos to monitor the CIP water quality to make sure that there is no flavor residue, inside the devices. And to wrap up, Alphamo's products, especially Enos, is a powerful decision tool. Qualitative models for accepting or rejecting samples based on determined organoleptic specifications. Quantification models for determining a compound concentration or sensory score. Benchmarking models for comparing the aroma profiles of several products. and outcome-based database for determining the chemical compounds involved in the related sensory nodes. Shelf life models for evaluating the change of sensory features over time. It's a multi-application system. We have customers using eNodes for quality control and for product development, for shelf life investigation, for shelf life project, and also for adulteration analysis, and also for testing coffee aroma and under different temperatures. Yeah, and also for softening residue in packaging materials, etc., etc. Yeah, a lot of different applications can be developed using Harcliffe eNodes. Yeah, this one is just a few customers of ours. Yeah, we have a lot more customers in different industries. Okay, this presentation is a quick introduction of Atomos, about our company and also about our products, and also a few simple applications. Yeah, so do you have questions about this presentation?
I'm sorry, may I?
Hello? Yeah.
Yeah.
Yeah, I can hear you. Yeah, please go ahead.
Thank you so much for a nice presentation. I'm very interested with your presentation actually. So maybe I missed or something. Do you have like any case that the consumer would like to have similar sensory profile with the natural, for example, like I would like to develop a mango flavor from the natural mango, and then you use this kind of method to develop that kind of flavor, like something like that. Do you have any case in your company for that?
Like
Thank you
consumer
so much.
which mango flavor, like how to select or how to design the mango flavor for some products.
Yeah, case like that. Because previously I seen your slide, there's like for about more quality control. Is there any case that you use this kind of method for product development, something like that?
Yeah, yeah,
Mm-hmm.
yeah, yeah. Yeah, first of all, the answer is yes, for sure.
Mm-hmm.
Yeah, and so yeah, to be honest, we have many we have customers, running different flavor samples like pineapple, mango flavor, etc. Yeah, and okay, maybe I'll show you this one. Yeah, this sample study is older analysis of cocoa powder. So we can see the samples description here. Yeah. And the analysis method. Okay. Also, let me see the.
Okay. Another question. Do you have like more data comparison, like comparing your data with the real sensory analysis, for example, something like, I don't know, using the panelists?
Yeah. Okay. Yeah, I get your point. Yeah. Actually, yeah, this tool, this analysis report is also, this is the raw data. So you can see in one raw data, there are 2 chromatograms.
Mhm.
And this one is older map, based on PCA
Mhm.
analysis.
Mhm. Mhm.
And this one is the, compound selection, selection of the most discriminant compounds in the PCA map. And this one is sensory data correlation. If we zoom in, we can see the sensory descriptors. So first of all, AlphaSoft, our software can also process human sensory data, and you can see the PCA map, based on the product and also the sensory descriptors, sensory scores coming from sensory panel. So we can see the PCA mapping here. We can see the sample DB3, GT4, and GG3, etc. If we go back, later, we will see the sample distribution in here. And so we can see the NE3, NE4, and this NE3, NE4. So we can
Also,
see
it's similar data with the
yes.
by using the panels.
Yes,
Sounds
yes.
good.
Yeah.
Yeah.
And
Thank you
then,
so much.
Yeah, you're welcome. Yeah, and also, if you want to achieve, the similar reader plot, like human sensory panel, we can also do that, but we need to build PS model for each sensory descriptor, like cocoa, like alkaline, like sour, etc. Yeah, and then we can have this one.
Okay. I'm sorry, one more. Do you use QDA for the sensory analysis, or what kind of sensory that you conduct for?
Okay. Yeah,
for
I
that?
understand. Yeah, QDA is often used in the typical human sensory data analysis software. Yeah, because we also cooperating with feeds, biosystems. Yeah, so we have some knowledge about the the statistical tools they can provide. Yeah, so in AlphaSoft, in AlphaMOS, like in the presentation, the mainly statistical tools are these. Yeah, like in Enos, we have sensor ID, we have PCA, SQC, DFA, shelf life, PRS, etc. Yeah, in Enos. In Eton, PCA, SQC, DFA, shelf life, PRS, and also taste screening equals taste ranking, and masking efficiency. Yeah, different models. Yeah, so it's I would say it's a little different with the QDA. Yeah, but in this study report, I just show you, by using PCA and PRS, sorry, to acquire those results. Yeah.
Thank you so
again,
much.
You're welcome. Yeah, again, if you already have some like statistical software, yeah, you can also process AlphaMOS those data using your software.
Okay, thank you.
You're welcome. Okay. Any other questions?
I think in chat, Mr. Rambo, how are you? Sorry, I just joined because I have class.
Nice to hear you.
Yeah. I think there's one question from Ibu Nila, yeah, in chat section. I think the question is, what is the difference between the AeroChem base and Enos system? She said that I still missing how it works in sensory analysis by using this quantitative apparatus. And if we using QDA, quantitative descriptive analysis, what is the difference? I think that's the question.
Okay. Quantitative descriptive analysis. Okay. Okay. So you know, within my knowledge, so for QDA, does the QDA provide the sensory profile like this one?
Mhm.
To you, am I right? Because I don't have much experience about the QDA. So is it the output of QDA is similar with this one? Am I right, Professor Rudy?
I'm also not not working with this kind of QDA. Maybe Ibu Nila there. Oke, mungkin boleh langsung kalau Bu Nila, Mbak Nila atau silakan.
Okay, thank you, Mr. Rudy. Okay, Mr. Rambo, I still confused with the using the apparatus by aerochem based and inner system, and actually, my knowledge, the QDA is quantitative descriptive analysis. What is the difference between the QDA and the aerochem based and inner system? Because the QDA is the same. It's quantitative analysis between QDA and the aerochem based system. So, what is the difference? Thank you.
Yeah, thank you. Yeah, I understand your question. Yeah, please allow me to find, a little introduction maybe from our systems. Yeah, then I will get more, information about this QDA example, because if I don't know the result, the output of QDA, then I cannot clarify the very well about the difference between outcome based and QDA. Sorry, I have some information, from my Japanese colleague, regarding the different, statistical analysis, by using other softwares or products. Okay.
Maybe I can.
Yeah. Because I'm personally, I'm still not quite sure about the QDA, output or example. So yeah, I want to check what is the QDA output. Okay, maybe I will.
Yeah, I think the instrument based on our system, yeah, actually is correlated between correlated between the sensory from data sensory panel correlated with the quantitative data from the instrument. Yeah. So I don't know, is it also can say as KDA? Maybe or Bu Nancy maybe can give any comment.
Okay.
Oke, bagaimana Bu Nila? Oke, nanti akan coba
kasih.
dicari penjelasannya
Ya,
mungkin ya.
Ya, mungkin
Ya.
pertanyaan saya itu mungkin sederhana aja ya Pak. Ya, kan QDA itu kan kita menggunakan apa? Behavioral sensor evaluation. Jadi ini kan dibandingkan dengan instrumen yang kita gunakan. Jadi pertanyaan saya itu bagaimana kita mensinkronaskan antara pembacaan dari hasil instrumen dengan QDA. QDA itu kan quantitative descriptive analysis. Yang kita melakukan pendekatan dengan menggunakan deskripsi panelis, ya responden yang kita gunakan untuk menilai sensori produk kita. Produk sensori kita apa, bagaimana. Jadi itu bagaimana dengan korelasinya dengan pembacaan dengan menggunakan aparatus, instrumen. Begitu Pak Rudi, terima kasih.
Ya. Oke. Kalau yang saya lihat dari apa yang saya cermati itu biasanya untuk untuk sensori indikatornya itu sebagai kelas begitu ya. Jadi nanti kan kita menggunakan pendekatan regresi begitu ya. Tadi saya lihat ada pendekatan regresi di dalam artinya kelas sensori itu dijadikan sebagai kelas sebagai parameter predicted yang akan diprediksi ya, sedangkan sensor itu kan juga ditentukan oleh komposisi kimia. Nah, apa yang diukur oleh saya kira di alat-alat Alfamos ini adalah tadi profil kimia yang menjadi faktor penentu dari kelas sensori yang ada, dan itu diperlihatkan di dalam korelasi regresi dalam bentuk saya lihat PLS begitu ya tadi. Mungkin seperti itu ya, apa itu KIDI sebut KIDI atau tidak saya nggak paham. Jadi pendekatannya begitu. Jadi mencoba membuat prediksi kelas berdasarkan data kelas yang dibangun dari panel ya, kemudian plus data yang dihasilkan dari hasil pengukuran alat itu sendiri.
Oke, terima kasih Pak.
Iya, seperti itu sih.
Ya, sama-sama.
Oke. Maybe is there any other question to Mr. Rambo?
Boleh, saya Esti, Pak Rudi dari BRIN.
Oh, okay. Please, Bu Esti.
Thank you very much for the time, Pak Rudi. It's a very interesting presentation, Mr. Rambo. I have a very simple question here. I'm interested in the use of this equipment and the software for shelf life analysis, whether this will be possible for shelf life analysis of processed products such as biscuits or instant noodle or other kind of coming from milk products like cheese or processed milk, something like that. Thank you.
Yeah, thank you for the question. Yeah, the answer is yes. Yeah, the answer is yes. Yeah, we also have some examples of shelf life study for the products you mentioned, and yeah, for information, we have this customer in the Philippines, the URC, they are using Enos, for product development and for shelf life study for their products. Yeah, the products you mentioned are quite similar to their product categories, like snacks, yeah, etc. Okay, maybe I quickly show you some. This one is a quality of bread and shelf life. So basically, it's a different time of the product, and can be stored at different temperature, etc. So in the PC map, we can clearly see the samples trend along with time or temperature. Now we can identify the most discriminating volatile compounds, and also we can compare the concentrations of these compounds in different products in different storage in time. So we can clearly see the concentration of these like rancidity or oxidization related compounds. Packaging impact, rancidity testing, rice cracker shelf life. Fresh, like fresh 1 to 6 months, 5-8 months. So we can find the trend on PC map is from right to left, from fresh to the longest storage in time. And so we can find the most related compounds with rancidity, or along with time, what compounds are increasing and what flavor compounds intensity are decreasing. We can have those kind of information. And also there are a lot of application notes and shelf life snap.
Okay. I'm sorry to ask again.
Yeah.
Well, okay. Do we need to process the sample before it is injected or introduced to the equipment, to the instrument? What I mean to say. So, is there and is it mentioned in together with the instrument, there is a method? There is a procedure or a guidance on how we should process the samples before going into the instrument. Is that available? Is it available with the instrument?
Yeah.
The procedure on how we should process the sample.
Oh yes. First of all, we will provide a fully installation and training to customers, provided by Alphamos or Alphamos partner. Normally for Enos, minimum 3 working days, for installation and training. And secondly, whenever you have question, you can click the help in here. So we will have this user manual. And the third, we will send to our customer the SOP about this like startup, run samples, diagnostic, run samples, data processing, and then shut down. So the whole operation procedure. And secondly, for Enos sample analysis, actually there is no sample preparation needed. So you can see the process in here. And we just use a balance or automatic pipette to take a certain weight or volume into the vial and put the cap and cream it and put the sample on the auto sampler tray, and that's it. And then you create a sequence in software, you click start, and that's it. And then the auto sampler and Enos, the software will run the samples one by one automatically. So all these are automatically done by the instrument. So this is the regarding the sample preparation. Yeah, so normally, there's no sample preparation needed with Enos.
Okay.
Okay. So it means that we can directly using the solid sample, yeah, Mr. Rambo.
That's interesting. If this is possible, yeah, Pak Rudi.
Yeah.
I would like to ask a short question to Pak Rudi.
Yeah.
If it's okay, it's okay.
Okay.
Is this instrument available in Biofarmaka, IPB?
Actually, PT Novatec actually, I think put the demo instrument still in our lab. Jadi so one demo instrument is in our lab until now. Still, yeah.
But can I bring some sample for the demo, or we have to pay for it?
I think maybe we can ask later to maybe Mbak Ika or from the Novatec.
Okay.
I think it can be free, Bu. It can be free.
Okay, so I contact you again, okay, Pak Rudi?
Yeah,
because
okay,
I have biscuits and I have instant noodle, which is needed some shelf life analysis. So if it's possible, thank you.
Okay, thank you. Okay, so maybe I think we still have the time for maybe is there any one or two questions from the audience? Okay, if no, I think okay. I maybe last question from me, Mr. Rambo.
Yeah, please go ahead, Mr. Lee.
Okay, yeah. When I'm experimenting and using the Heracles now, so I just try to get the raw data from the software. So yes, I wonder actually which part of the data that used for chemometric analysis for PCA. Is there did the Heracles do the Heracles use the data from chromatogram or from the intensity from the detected compound?
Oh, okay. Yeah, I understand your question. Yeah. So yeah. Maybe I just put an example. Yeah, for example, we select one raw data.
Okay.
Chromatogram in here. Yeah. And then in here, we will have this integration table.
Okay. Yeah.
Yeah, for the peaks, two different columns, right?
Okay.
And then you may wonder, how what the PCA is coming from.
Yes.
Yeah. So for this, it's like this one. For example, we I click one. Maybe just sorry. Let's say maybe I just click this one and label it, and then we can run PCA, right? Yeah, we can run PCA. So you may wonder, where the PCA is coming from. If we look at the sample table in here, we can see the sample from G1 until G10, B1, B2 until line 1 to 6, so many samples. The data is actually coming from here.
Okay.
Yeah. So we can see the, a number and -1. So the number right now is the retention index of the peaks. Yeah, in here. So you can see all the peaks in here. So index means the first peak on the first column. And -1 means the first column, and -2 means the second column. So the capital A means area, integration area, the range corresponding to the integration area and discrimination power. Yeah. So we can look, if we look at the table, we can find, you know, from the beginning in the first peak until the last peak, you know.
Okay. Yeah.
The last peak on the first column, and then the first peak on the second column.
Okay.
Till the end. So this is the, you know, like the data matrix where the PCA is coming from. So by default, all these, you know, by default, all these data are selected. Yeah.
Okay.
Yeah. So this is
Okay.
this is how the PCA, you know, is coming from.
Okay. Thank you very much. Okay.
You're welcome.
Yeah.
And secondly, yeah, I want to answer your, you know, your question in here. So outcome base and, you know,
Yeah.
outcome base is from this menu. You can see outcome base is you know, one menu in Microsoft, right? Yeah, of course, we have outcome base standalone, you know, version, but the information is the same. So yeah, for example, there are multiple usage of outcome base. Yeah, first of all, if we want to find out, you know, some information about the compound we already know, so we can just put, for example, X.
Okay.
Yeah, we can just put the name in here, or we can just put the case number in here. Yeah, we click search. Then we can have this compound information, all information in here, right? And so this is one usage. And secondly, if we are developing some product, or we want to find out some product, for example, palm oil. I'm not sure we have palm oil inside. Yeah, let's just try. Oh no, then let's try just maybe just oil. Then we can find, you know, many information about the oil, you know, documents or publications, you know, collected by Avamos. Yeah, inside all these papers, there are, you know, many information inside, such as, you know, compound list and flavor comparison, yeah, etc. And then we can do compound identification, you know, after quartz retention, after, you know, like quartz calibration.
Okay.
Yeah, so right now we can see the x-axis is retention time, right? So it's the peak elution time on the chromatogram. Yeah.
Okay.
And then by right click, we can display the retention. We can switch from retention index to from retention time to retention indices. We can have this one, right? So for example, I just manually identify the peak. You know, here it's 1310. Yeah, we put the retention index inside, and then you can find the possible compound list in here. Yeah, so it's a manual one. And secondly, we can use, you know, this automatic, you know, compound ID. For example, I just filter out some peaks so that we can do it very fast. You know, just for demonstration, just for show you. So by modifying the you know, minimum peak area in the integration option, we can filter out, you know, some compounds, and then we can use this function. we can use parameter identification. For example, like 40 or maybe 50 as you wish. And then we will have this, it's like a automatic identification list in here.
Oh, okay.
Yes. And then, so this is, two different ways. One is manually we can identify, and secondly, we can use the document search.
Okay.
Especially for some typical, products we want to find, such as noodles. Etc. So actually we can find more information inside this database. So this one is the outcome-based database. We can have different information by using different ways, and to find compound information and help us to identify the compound. So this is outcome-based database. It's different with QDA, but although I'm not quite familiar with QDA, but I assume QDA is kind of it's like we input the human sensory data into this QDA software, and then we can have some result, maybe like this reader plot. Maybe, right? So if we want to use eNodes to acquire similar result, like this flavor wheel for our product, the common way we recommend is to build PRS model, for each sensory descriptor, artificial, brown sugar, caramelic, woody, etc. So which means we need to have this this data from panelists first, and then after we build the PRS model, we don't need to we don't need human sensory panel to evaluate the product again, because by using PRS model, we can provide similar results in the reader plot as human. So if you want to know the process, it's also it's not complicated. It's for example, this PRS, we can see there is entity or descriptor with scores, right?
Okay.
With scores, and then in here we can click this sensory score correlation. This one is the PRS mode, and then we can identify the raw data. For example, you select one raw data. I just select random one, so the score maybe very maybe out of it, or it's in here. So in here we can see the score, mean value in here. So this is the sensory score, and also in here we can add different descriptors, like caramel, like rusty, just random thing, like roasted, etc. And then in here we can input the score, like 1, 2, 3, 1.2, etc. So we can input scores, in here. And then when we build PRS model, we can see all the different descriptor PRS model will be built in the same time. Yeah. And, I just put some random score inside, it's not the real, panel data.
Okay.
Yeah. So then we have all these, we have this, model for every descriptor, and then we can project the raw data, the product we want to analyze into this model. Yeah, and for the score, we will see the score in here. We'll see the score in here. Yeah, but there is no, no reader plot yet. Yeah, but once we have the score, for roasted or rusty or caramel, etc., we have the score in here, and then we can use Excel or maybe Word or PowerPoint just to simply draw this map. Using Excel. Yeah, it's very quick and easy to have such reader plot. Yeah, so this is the process of how to use Enos. Yeah, to provide this reader plot, for our products. And beyond that, as you already know, PCA, odor comparison result and compound identification, and the relative content of each compound in our product, etc. All these and also shelf life, monitoring, etc. can be achieved. And for solid sample, yeah, just for example, this one is not food, but it's we do have some customer in the plastic industry. They are providing packaging for food industry. Yeah, so you can see the recycled plastics, so the PET bottle. So they need to, during recycling of these packaging materials, they need to make sure, the residue content is very low, especially compounds like, benzene, limonene, and also, other compounds, like this one, Winsol, etc. They have very strict regulation, about these compounds. So by using Enos, first of all, Enos is sensitive enough, to go to PPB level to meet their requirements. And secondly, Enos is very fast. And then we can do compound quantification, with the calibration wizard. It's actually, we open the library. When we open a raw data, for example, we will find the quantification calibration wizard. It's for compound quantification. Yeah, so it's just follow the wizard. We can build this one, build the calibration curve, build this one. Yeah, to calculate the exact amount of these chemicals. Yeah, so we can see the detection limits. For benzene, it's around 0.5 ppb. Yeah. So for no matter solid sample or half solid, half liquid, or liquid sample, a plastic, foam, yeah, basically everything. Yeah, we can run the samples with Enos and acquire different application purposes. Yeah, and to be honest, for today's meeting, I prepared all these different type of applications, but we don't have enough time to go through all these reports. But a few one, like quality control, shelf life, this benchmarking, flavor review, sensory correlation, yeah, edible oil adulteration, and contamination, quantification in plastics, shelf life snacks, a pet food application, and milk application, rancidity, yeah, quality control of juice, etc. And there are a lot of different applications. And inside the application notes, yeah, you can see how many different things.
Okay, so
Mm.
this one is already used for wide range of product and process, yeah, Mr. Rambo. Okay, so
Oh yes, yes. So that's why we call it a multi-application system, and yeah, a lot of different applications can be developed, and also we already did some applications. Yeah, for example, I can show you this presentation. It's like yeah, benchmarking of yogurt, and because different fermentation strains can be tested. The customer is using different strains for this fermentation. And this one is shelf life model in here. It's for yogurt. Customer is mainly for the taste. Is focusing on the sourness and also sweetness. So we can using shelf life model, we can see visualize the flavor variation trend at different time. And also the compound, relative compound, and the sensory distributor and odor thresholds. Juice, quality control, of odor investigation, and quality control. So we can find the fermented compound existing in the juice product. And then, QC models, origin tracing, or classification for coffee beans. Yeah, color and shape analysis of coffee beans. Quality control model, and tea, water, like soup, pork bone soup, CRP water. Yeah, tobacco. Liquor. Oil and fats. Meats.
okay.
Seasonings. Pet food. Nutrition. Rice. Fruit. Pharmaceutical. Yeah, packaging. Personal care. Flavor and fragrances. Chemicals and materials. Now this one is automobile industry. Yeah, they're using POS, for odor grading. Pet food. There's some publications. Yeah, our French colleague, in France, actually we have colleagues. They are collecting the publications, every season, every 3 months. Yeah, and then so for the publications, there are a lot of papers, can be found. Yeah. So yeah, if you are interested in some, product, categories, for example, snacks, etc., we can provide the literature or the publications list to you.
Okay. Thank you, Mr. Rambo.
You're welcome.
Okay.
Professor.
Yeah. Yeah, I think that's our session is come to the finish time. So I think I can summarize that from the interesting presentation that we saw that combination between the instrument data and then with the other data can be correlated with and I think it's already applied put in practice. Yeah, we saw with the I think the instrument available from the Metabolomik and Alphamos. Okay, so I think that one also already applied for a wide range of product and process. It means that I hope that we all get the inspiration how that the process from the research become the commercial activity in developing the process. I think that's maybe what I can summarize. Again, I think thank you for Ms. Rambo from Alphamos, and also thank you for I think team from the Novatech that already provide the also contact to Ms. Rambo. I think that's for today webinar session. Maybe we can also join again with the other session from the forum Metabolomik Indonesia. Once again, I think thank you for the nice presentation. Thank you for you all for attending also this webinar. I think I give back to the Mbak Alfi.
Yeah, thank you, Professor Rudy, and all attendees today. And
Okay.
any other questions for me?
I think I think that's already all the question. Maybe if there's any question later, I think we can drop to contact from the Novatech. Yeah, it's okay.
Yes.
Yeah. So I think some colleagues ask if maybe a file for your presentation can be shared with us. I think it's okay if I think we get it from the Novatech.
Yes, of course.
Okay. Okay. I think thank you, Mr. Rambo and all the audience. I think we can see you again for the next webinar from Forum Metabolomik Indonesia.
Yeah, sure. Thank you.
Okay, thank you. Okay, Mbak Alfi. Okay, I think it's already finished. I think thank you for the session. We can end this session.
Yeah. Okay. If no further questions, but as Professor Rudy mentioned, if you have any questions, please feel free to contact Novatech. Yeah, and we will answer your questions, any more concerns regarding Alphamos.
Yes.
Yeah.
Okay.
Okay. Again, thank you all for your time. Yeah.
Okay.
Yeah. Thank you.
Okay. Thank you. Yeah. See you again is another occasion. Okay.
Yeah.
Bye bye.
See you again, Mr. Rudy.
Yeah.
Yeah. Bye bye. Thank you. Bye bye.
Okay. Oke, saya izin live ya. Terima kasih semuanya.